Let's begin by graphing the function f of x equal to the square root of x. One thing that we might note about this function is that the domain would extend from 0, including 0, up to infinity. If we are to graph this in a real set of coordinate axes, then the variable x can only take on values that are at least 0, in other words, values that are non-negative. The range then will also go from 0 to infinity, including 0, since taking the square root of a positive number always results in a positive number. So let's substitute some convenient values for x and find the corresponding y values. We will use 0, 1, 4, and 9 since they are perfect squares and will result in integer values for y. When we graph these ordered pairs, we wind up with a function that is actually the top half of a parabola that opens to the right. Now let's look at what happens when we substitute the opposite of x for each of these x values. The domain then will go from minus infinity to 0. So each of the x values will have to be negative so that once the opposite is applied, the result is a positive value. The range then will again go from 0 to infinity. So this time, when we substitute values for x, we will need to use negative numbers. Again, we will use the convenient values that are perfect squares. When we graph this function, we find that it is actually a reflection through the y-axis of the original function. This time, let's apply the negative to the entire function rather than to the x values. Our domain again will go from 0 to infinity, since we will be taking the square root before we apply the negative. The range, however, will then go from minus infinity to 0, since we will be applying a negative value to a positive number in each case. So our convenient x values will again be positive, and the resulting function values this time will be negative. When we graph this function, we see that it is a reflection of the original function through the x-axis. So let's make some generalizations about reflecting graphs. To graph y equals f of negative x, in other words, applying the negative to the x, reflect the graph of y equals f of x in the y-axis. To graph y equals the opposite of f of x, in other words, applying the negative to the entire function, reflect the graph of y equals f of x in the x-axis.